Question 7a. Using completing the squares method, solve correct to 2 decimal places. S minus 2 over 4 equal to s plus 2 over 2s. What this means is that if this equation is simplified by clearing fractions, the result is going to be a quadratic equation of this form. So this is the given equation. To simplify, multiply through by 4s, the LCM of the denominators, 4 and 2s, to clear fractions. If you multiply this term by 4s, 4 will remove 4, only s is remaining, that will multiply the numerator. If you multiply this term by 4s, 2 is remaining, that will multiply the numerator. So open the brackets. If you open this bracket, you have s squared minus 2s equal to 2s plus 4. If you rearrange so that the right hand side is 0, you have to transfer 2s plus 4 to the left hand side, and you have s squared minus 2s. If you transfer plus 2s to the left hand side, becomes minus 2s. If you transfer plus 4, becomes minus 4 equal to 0. If you add like terms, you have s squared minus 4s minus 4 equal to 0. We now have a proper quadratic equation. We can then apply the procedures involved using completing the squares method. This method involves a number of steps, so I'm going to outline the steps and use them to solve the equation. Step 1. Make the coefficient of s squared unitary. The term that is squared, whether s or not, its coefficient is always 1. That is unitary. In the given equation, the coefficient of s squared is already 1. So the equation remains the same. Step 2. Transfer the constant term to the right hand side. This is the constant term. If you transfer it, it becomes plus 4. So you have s squared minus 4s equal to 4. Step 3. Add square of half of the coefficient of s to both sides. In step 2, the coefficient of s is minus 4. So you get half of minus 4 and you square it. That means 1 over 2 is half times minus 4 all squared. So you have minus 2 all squared. You add this term to both sides. So the first side is s squared minus 4s plus minus 2 squared equal to the right hand side. You have 4 plus minus 2 all squared. Step 4. Ignore the term that contains s and simplify the right hand side. This term that contains s minus 4s, you ignore it. If you ignore it, you are left with s squared plus minus 4 minus 2 in bracket, then you square it. As you are doing that, you simplify the right hand side. So you have 4 plus minus 2 squared is plus 4. When you add, that gives you 8. Step 5. Combine the squares on the left hand side. These two square, s square and this square, you combine them. It's a form of factorial add power 2. If you do that, you have s minus 2 all squared equal to 8. Step 6, take square roots of both sides and solve the linear equation. You take the square root of the first side. You know, in quadratic equation, we always have two roots. To achieve that by this method, anytime you are taking the square root of the right hand side or the rational number, you always attach plus minus. So you have plus minus root 8. The left hand side, the square root will remove square. You are left with s minus 2 equal to plus minus root of 8 is 2.828. So you solve the linear equation. First, you transfer minus 2 to the right hand side. It becomes plus 2. That term plus and minus is always in the middle, so the 2 you transfer will comes first. So you have s equal to 2 plus minus 2.828. The plus minus means you write the expression 2 times starting with minus. So s is equal to 2 minus 2.828 or 2 plus 2.828. If you subtract and add, you have s equal to minus 0.828 or 4.828. So 2dp will consider 8.2 and 8.2. If you approximate, you have minus 0.83 or 4.83. That is what you should have here. That is the answer to 2 decimal places. Question 7b. In the diagram, PQRST is a circle with center O. If PS is a diameter, ROS parallel QT, Q arrow equal to ROS, and angle QTS equal to 5 degrees. Find, remember figure 1, angle SQT. Remember figure 2, angle PQT. So we have a solution. Now from here, we are told that PS is a diameter. That means this angle is 90 degrees. That is angle in a semicircle. So we have little adjustment in diagram before we proceed by looking for the required angles. Remember figure 1, you have to find angle SQT. Let us start this way. Let's take Q arrow ST as a quadrilateral, and you have this angle and this angle. They are interior opposites, and their sum is 180. So you have angle QROS plus angle QTS equal to 180. Interior opposite angles of a quadrilateral. So we have angle QROS, QTS is 52 degrees equal to 180. To get QROS, you transfer 52 to the right hand side, and you have 180 degrees minus 52 degrees equal to 128 degrees. Now let us consider triangle QROS. By these two markings, it means that triangle QROS is isosceles triangle. For that reason, the base angles are equal. So you have angle ROQS is equal to angle ROSQ, base angles of isosceles triangle. So if you add the three angles in the triangle, their sum is 180. Now these two angles are equal. That means you can take any one. So here I'm using ROSQ equal to ROQS. When you add both, you have two angles ROQS. You transfer this angle to the right hand side and you have 180 degrees minus 128 degrees equal to 52 degrees. Divide both sides by 2, you have ROQS equal to 52 degrees divided by 2, and that is 26 degrees. So this angle 26 and this angle is also 26. Now let us check SQT. You are asked to find SQT. That is S, you have Q and T. We have it that angle SQT, that is this angle SQT, this angle is equal to ROSQ, that is this is ROSQ, that is this angle that you have here. What is the reason? Alternate angles, because ROS is parallel to QT. So letter Z is fashionable from this place. That is why SQT is equal to ROSQ, alternate angles. Second part is to get angle PQT. Angle P, okay, we have angle PQT. That is this angle now, this angle PQT. First, we have it that angle PQS is 90 degrees. The whole of this angle 90 degrees, angles in a semicircle. Now this angle is already 26 and the whole angle is 90. It means this remaining part is 90 minus 26 degrees. So therefore angle PQT is 90 degrees minus 26 degrees, and that is 64 degrees.